Hello and welcome to my first Raspberry Pi video on connecting a 7-segment LED display via the I2C interface using a MCP23008 chip. I'm assuming here that you are already familiar with what the Raspberry Pi is and what the GPIO header on the Pi is. If not, I suggest you start with the excellent video explaining the GPIO controls and functionality from explainingcomputers.com. I have included a link to that video in the comments below. For this project, I'm not going to be using the general purpose I/O directly from the Raspberry Pi, but rather a data interface called I2C. Before we commence the setup, let's have a look at what I2C is. I2C is a dual-wire serial bus, which uses, funnily enough, 2 wires to communicate with a compatible device. It stands for Inter-Integrated Circuit and was developed by Philips in 1982. Combined with the 2 wires for power and ground, I2C enables communication across multiple chips using only 4 wires. This means that on our Raspberry Pi we don't have to use up all our precious GPIO pins to drive directly attached devices, but rather can send byte commands from our Pi to a chip or several chips, which will drive the device for us. What I am going to create in this series of videos is an I2C connection from the Raspberry Pi to a 7-segment LED display using an MCP23008 integrated chip to perform the actual controls. The 7-segment display actually has 8 controls if you include the decimal point, so the MCP23008 is the perfect choice to control it, as it has a total of 8 configurable pins. I could also use the MCP23017 chip, which has the same configuration but offers 16 configurable pins. Before all that though, the first thing we need to do is enable I2C on the Pi. I have a Raspberry Pi 2, but the process is rather similar for the earlier versions also. The first place to start is the Raspberry Pi config, so grab a terminal and type in sudo raspi-config. Under the advanced options, you will find the I2C setup. We're going to enable this and make sure that the module is loaded by default. The next thing we're going to do is ensure that the correct drivers are loading at startup. So go to etc modules. By default, the Raspberry config that we just did will add the I2C BCM2708. We need to add the I2C-dev line. The next file we need to edit is the boot config file. You can search this file for I2C. Note here that the DT parameter for I2C is still commented out. However, what the Raspberry config has actually done is add it to the end of the file. So if we search again, we will find at the end of the file that it has added the I2C_arm equals on parameter. Immediately before this, add DT param equals I2C1 equals on. For earlier Raspberries, this will probably be I2C0 equals on. For good measure, I typically reboot the Pi about now. Once the Pi is rebooted, jump into your terminal again and run sudo modprobe I2C-dev. To check that the modules have loaded correctly, we can run the ls mod command. I'm going to grep I2C. This will display only the I2C modules, and we can see here that both BCM2708 and the dev modules have both loaded. The next commands are the apt-get ones. Run a sudo apt-get update command to make sure that everything is up to date. Mine is already done, so I'm going to skip this step. We're then going to install the I2C tools and the Python SM bus. This can be done using sudo apt-get install I2C-tools and Python-SM bus. Mine is already installed, so there's nothing to do, but it'll take a couple of minutes to finish. For good measure, I normally reboot at this point as well. Make sure you use sudo reboot and don't just pull out the plug on the Pi. Now that we have set up I2C and installed some tools to use it, we're going to make sure that we can detect what is on the I2C interface. To do this, I'm going to run the I2C detect command, using -y to suppress any prompts to say yes I'm sure, and because I'm on a Raspberry Pi version 2, I'm going to specify bus number 1. If you're on an earlier version of the Pi, you'll need 0 here. I can see that I can communicate to the I2C bus, and nothing is currently detected. Now that the I2C interface is up and running on our Pi, we need something to connect it to. In my next video, Part 2, I will demonstrate the connection of the MCP23008 input-output expander.